Hi everyone. In the previous lecture, we have seen dot product of two vectors. In the previous lecture, we have seen dot product of two vectors. The definition of dot product, remarks or some properties of dot product of vectors. Also, we have seen how to find out the angle between any two vectors. Now today we are going to see the examples on dot product of two vectors. So see, first question, determine whether A bar and B bar are orthogonal parallel or either. See, first sub question, A bar and B bar are given. See here, A bar is equal to minus I cap minus 9 I cap plus 6 J cap plus 15 K cap, and B bar is also given. It is 6 I cap minus 4 J cap plus 10 K cap. 6 I cap minus 4 J cap minus 10 K cap. Now see the question, determine whether A bar and B bar are orthogonal, parallel or either. Orthogonal means perpendicular. So we have to determine whether these two vectors A bar and B bar are orthogonal means perpendicular, parallel or either. So let's see, let A bar is equal to minus 9 I cap plus 6 J cap plus 15 K cap, and your B bar is 6 I cap minus 4 J cap minus 10 K cap. Now A bar is equal to minus 9 I cap plus 6 J cap plus 15 K cap. This is your given A bar. Now from each term, here it is minus 9, 6 plus 15. So if we take minus 3 common, so the remaining vector is 3 I cap minus 2 J cap minus 5 K cap. Or again it is equal to minus 3 by 2 into, here we have divided to this vector by 2, so we have to multiply. Means in this case, in this step we multiply and divide the expression by 2, so we get minus 3 by 2 into 6 I cap minus 4 J cap minus 10 K cap. A bar is equal to minus 3 by 2 into this vector, but if we see the vector B, then what is vector B? 6 into I cap minus 4 J cap minus 10 K cap. So which is equal to minus 3 by 2 into B bar. So here A bar is equal to minus 3 by 2 into B bar. Means A bar is scalar multiple of B bar. So therefore A bar is scalar multiple of B bar. And we know that in the definition of collinear vectors, if one vector is the scalar multiple of other, then these two vectors are collinear, means they are parallel. So here A bar is scalar multiple of B bar, so therefore A bar is parallel to B bar. Means in first sub-question your A bar is parallel to B bar. Now second sub-question, A bar is equal to, the question is A bar is equal to 2I cap plus 3J cap minus K cap. B bar is equal to 5I cap minus 2J cap plus 4K cap. See here, A bar and B bar are given. We have to check whether A bar is parallel to B bar or whether A bar is orthogonal, means perpendicular to B bar, or whether, or both. Either means both. So let A bar is equal to 2I cap plus 3J cap minus K cap, and B bar is equal to 5I cap minus 2J cap plus 4K cap. Now A bar dot B bar is equal to, now take the dot product of these two vectors. So A bar dot B bar is equal to 2I cap plus 3J cap minus K cap, its dot with 5I cap minus 2J cap plus 4K cap. Take dot product. We know that the dot product of these two vectors is 2 into 5 plus 3 into minus 2 plus minus 1 into minus plus 4. So it is 10, 3 into minus 2 minus 6, minus 1 into 4 minus 4. It is equal to 10 minus 10, and it is equal to 0. So A bar dot B bar is equal to 0, and we know that if the dot product of any two vectors is 0, then these two vectors are orthogonal, then these two vectors are perpendicular. So therefore A bar dot B bar is equal to 0. This shows that A bar is perpendicular to B bar. So therefore A bar is orthogonal to B bar. So in this way we can check whether the vector is orthogonal or parallel. Second sub-question, third sub-question here. A bar is equal to 4I cap minus J cap plus 6K cap, and B bar is equal to 5I cap minus 2J cap plus 4K cap. Let A bar, that is given 4I cap minus J cap plus 6K cap, and B bar is equal to 5I cap minus 2J cap plus 4K cap. Now take dot product of these two vectors, A bar dot B bar, it is equal to 4I cap minus J cap plus 6K cap, its dot with 5I cap minus 2J cap plus 4K cap. Now the dot product of these two vectors, 4 into 5 plus minus 1 into minus 2 plus 6 into 4. So it is equal to 4 into 5 20, minus 1 into minus 2 plus 2, and 6 into 4 24, which is equal to 46, which is equal to 46. So A bar dot B bar is equal to 46. It means here A bar dot B bar is not equal to 0. A bar dot B bar is not equal to 0. So therefore the vector A bar is not orthogonal, means not perpendicular. Orthogonal म्हणजे perpendicular, is not orthogonal to B bar. A bar is not orthogonal to B bar. Also, if we observe A bar and B bar, see, if we observe A bar and B bar, here we can't write A bar as scalar multiple of B bar or B bar as scalar multiple of A bar. So therefore, here also A bar is not scalar multiple of B bar. A bar is not scalar multiple of B bar. It means that A bar is not parallel to B bar. So in this sub question, A bar is not orthogonal to B bar and A bar is not parallel to B bar. A bar is not parallel to B bar. Hence A bar is neither parallel to B bar nor orthogonal to B bar. Means A bar is not parallel to B bar as well as A bar is not orthogonal, means A bar is not perpendicular to B bar. So we see next question. Find angle P of triangle. Find angle P of triangle whose vertices are P, capital P having coordinates 0, minus 1, minus 2, Q, 3, 1, 4 and R, 5, 7, 1. So here these 3 points are vertices of triangle and we have to find out the measure of an angle P. So we see, let small p bar, small q bar and small r bar be position vectors. P dot V dot means short form मध्ये position vectors of vertices P, Q, R respectively. So therefore small p bar is equal to, the vertices are here 0, minus 1, minus 2. So the position vector of this point is small p bar and it is equal to 0 I cap minus j cap minus 2 k cap. Similarly, small q bar is the position vector of the point capital Q. So position vector q bar is 3 I cap plus j cap plus 4 k cap and r bar is equal to 5 I cap plus 7 j cap plus k cap. You know that, see this p bar P, Q and R. This is triangle PQR. And we have to find out the measure of an angle P. Now angle P is the angle between PQ and side PR. So angle P is the angle between two vectors PQ bar and PR bar. Angle P is the angle between two vectors PQ bar and PR bar. Now we find PQ bar and PR bar. Now PQ bar is equal to Q bar minus P bar is equal to. Now see, Q bar minus P bar. 3I cap minus 0I cap, 3I cap. J cap minus minus become plus, J cap plus J cap, 2J cap. 4K cap minus of minus become plus, 4K cap plus 2K cap, 6K cap. So PQ bar. Similarly find out PR bar. PR bar is equal to R bar minus P bar. Again it is equal to R bar minus P bar. See, 5I cap minus 0I cap, that is 5I cap. 7I cap minus of minus become plus, 7 plus 1, 8J cap. K cap minus of minus become plus, K cap plus 2K cap, 3K cap. So PQ bar is here, PR bar is here. Now take the dot product of these two vectors. Now PQ bar, its dot with PR bar is equal to PQ bar and PR bar are given here. It is equal to 3I cap plus 2J cap plus 6K cap, its dot with PR bar. What is PR bar? 5I cap plus 8J cap plus 3K cap. So again it is equal to, take the dot product of the 3 into 5 plus 2 into 8 plus 6 into 3. Again it is equal to 15 plus 16 plus 18. And it is equal to 15 plus 16, 31, 31 plus 18, that is 49. So PQ bar, its dot with PR bar is equal to 49. Now by the definition of dot product, see here, if A bar and B bar are any two vectors, then A bar dot B bar is equal to magnitude of vector A into magnitude of vector B into cos of angle between them. If theta is the angle between them, then this is the formula. Now here PQ bar dot PR bar in the form of definition of dot product can be written as, now or also PQ bar, its dot with PR bar is equal to magnitude of vector PQ bar into magnitude of vector PR bar into cos of angle between them. See, the angle between PQ bar and PR bar is P, so it is cos of P. So from this, cos of P is equal to, cos of P is equal to, see, PQ bar, its dot with PR bar divided by magnitude of PQ bar into magnitude of PR bar. Again it is equal to, see, PQ bar dot PR bar, that is 49, divided by magnitude of vector PQ, that is square root of, see, PQ is here, that is becomes 3 square plus 2 square plus 6 square into magnitude of vector PR bar. and PR bar is this one, that is 5 square plus 8 square plus 3 square. So again it is equal to 49 divided by 3 square, the square root of 3 square 9, 2 square 4 plus 6 square means 36 into square root of 5 square 25, 8 square 64 and plus 3 square become 9. So cos of P is equal to (49) divided by, see 9 plus 4 13, 13 plus 36 49, square root of 49 into square root of 25 plus 9 34 and 34 plus 64 98, it is 98. Again it is equal to 49 divided by square root of 49, means this is 49 divided by, it is magnitude of vector, so it is always positive, that is 7 into this 92. This 92 can be written as square root of 49 into 2 and square root of 49 is 7, so it can be written as 7 into square root 2. This square root of 98 can be written as 7 into square root of 2. Again it is equal to 49, 7 into 7 49, 49 divided by 49 into square root 2. Now this 49 get cancelled, it is 1 upon root 2. So cos of P is equal to 1 upon root 2, and 1 upon root 2 can be written as cos of 45 degree. So cos of P is equal to cos of 45 degree. Therefore, angle P is equal to 45 degree or pi by 4 radian or pi by 4 radian. So here the angle P is 45 degree or pi by 4 radian. We see next problem. Small p bar, comma q bar, comma r bar are unit vectors. Find first one, p bar, small p bar dot q bar, and second sub question is p bar, small p bar dot r bar. Also in the problem the figure is given. This is p bar, this is q bar, and this vector is r bar. Means in the problem p bar and q bar are unit vectors, but p bar, q bar, r bar lies along the sides of a triangle. Let vertices of a triangle are A, B, C. Means this triangle is A, B, C. Triangle is ABC. Let small p bar, q bar, r bar are unit vectors. You know that unit vectors means their magnitudes are 1. So magnitude of vector p is equal to magnitude of vector q is equal to magnitude of vector r is equal to 1. Now see, means the vector p is along the side AB, so AB bar is p bar. Vector q is along the side BC, so BC bar is q bar. And vector r bar is along the side AC, so AC bar is equal to r bar. So whatever be the length of the segment AB is the magnitude of vector p. The length of BC is the magnitude of vector q, and length of AC is the magnitude of vector r bar. So length of AB, see, magnitude of vector p is equal to magnitude of vector q is equal to magnitude of vector r, means length of AB is equal to length of BC is equal to length of EAC. Because here you may write also AB bar is equal to P bar, BC bar is equal to Q bar, and AC bar is equal to R bar. So length of AB is equal to length of BC is equal to length of AC. So therefore this triangle is equilateral triangle. Therefore triangle ABC is equilateral triangle. And we know that in equilateral triangle, the three sides are equal, as well as the measure of three interior angles are also equal, and they are 60 degree. So angle A is equal to angle B is equal to angle C is equal to 60 degree. If we take the dot product of AB bar and BC bar, dot product of AB bar and BC bar. Now AB bar, its dot with BC bar is equal to, what is the definition of dot product of any two vectors? I will write the definition here. A bar dot B bar is equal to magnitude of vector A into magnitude of vector B into cos of angle between them. Now AB bar and BC bar, AB bar and BC bar, the vectors are P bar and Q bar, and the angle between them is B. So directly here you can write cos of B is equal to, cos of B is equal to P bar dot Q bar divided by magnitude of vector P into magnitude of vector Q. P bar dot Q bar divided by magnitude of vector P into magnitude of vector Q by using the definition of dot product. But angle B is 60 degree, so therefore cos of 60 degree is equal to P bar dot Q bar divided by magnitude of vector P, that is 1, into magnitude of vector Q, that is 1. So cos of 60 degree is equal to P bar dot Q bar. But what is cos of 60 degree? That is 1 by 2. So 1 by 2 is equal to P bar dot Q bar. So here we have P bar dot Q bar is equal to 1 by 2 because cos of 60 degree is equal to 1 by 2. This is the reason. So we have P bar dot Q bar. Now we have to find out in second sub question P bar dot R bar. P bar dot R bar, second sub question. Now see, P bar dot R bar means we have to consider the angle between P bar and R bar, P bar and R bar, angle between P bar and R bar is this one, A. So we have cos of A is equal to P bar dot R bar divided by magnitude of vector P into magnitude of vector R. Again it is equal to P bar dot R bar divided by magnitude of vector P, that is 1, into magnitude of vector R, that is also 1. So therefore cos of A, but what is angle A? Measure of an angle A is 60 degree here, 60 degree. So cos of 60 degree is equal to P bar dot R bar divided by 1. That is cos of 60 degree is equal to P bar dot R bar. And we know that cos of 60 degree is 1 by 2 is equal to P bar dot R bar. So therefore P bar dot R bar is also 1 by 2. So this is the complete solution for the given question. Prove that by vector method. Prove that by vector method the angle subtended on a semicircle, the angle subtended on a semicircle is a right angle. Now see, this is one of the property of circle, and that property can be proved by vector method, in particular by using dot product. So let's see the proof of this property. Let AB be a diameter of circle which center at origin O, with center at origin O. So this is the circle. Here this is diameter AB, the center of the circle is O. Let P be any point on the circle other than A and B. Means here we have taken a point P on the circle other than A and B. So if we take the point is here like this, suppose this point is P. Now join AP and BP. If we join AP and BP, then the angle APB lies in semicircle. Angle APB lies in semicircle. Therefore, the angle APB lies in a semicircle. Lies in a semicircle. Now, in this here we have to show that angle APB is of measure 90 degree. Angle APB is of measure 90 degree means side AP or the segment AP is perpendicular to PB or BP. The angle between these two sides is 90 degree, that we have to show. So the angle APB lies in a semicircle. Let A bar comma B bar comma R bar be the position vectors of points A, B, P respectively. So here OA bar is A bar, OA bar, this is A bar, and OB bar, this is B bar, and this vector OP bar, this is R bar. This is R bar. In particular, OA is radius of the circle, OB is radius of the circle, and OP is also radius of the circle. So magnitude of, so therefore magnitude of vector A is equal to magnitude of vector B is equal to magnitude of vector R, because they are radius of the circle. Also OA bar and OB bar, they have equal magnitude but opposite direction, OA bar and OB bar. So here we can write OA bar is equal to minus of OB bar, or OB bar is equal to minus of OA bar. It means B bar can be written as minus of A bar, or A bar can be written as minus of B bar. So from this one, it is A bar is equal to minus B bar, means B bar is equal to minus of A bar. Among these two, you can write any one of them. A bar is minus B bar, or B bar is minus A bar. Now here we have to show that AP is perpendicular to PB. Now here we check the dot product of AP bar and PB bar. Now, we see here. Now, AP bar, its dot with PB bar is equal to. By using the definition of position vector AP bar, this is nothing but position vector of the point P, that is R bar, minus position vector of the point A, that is A bar, its dot with PB bar. It is position vector of the point B, that is B bar, minus position vector of the point P, that is R bar. Again it is equal to. See, distribute this dot product over subtraction. So it is R bar dot B bar minus R bar dot R bar. Now distribute this dot product by this minus of A bar. So minus of A bar dot B bar, minus of A bar dot minus of R bar, it means it becomes plus A bar dot R bar. Again it is equal to. But we know that B bar is equal to minus A bar. B bar is equal to minus A bar. So R bar dot minus A bar. R bar dot minus A bar, because B bar is minus A bar. Minus R bar dot R bar minus this B bar can be written as minus A bar. Minus A bar, its dot with minus A bar, plus A bar, its dot with R bar. You may write the reason here also. B bar is equal to minus A bar. The reason is here, B bar is equal to minus A bar. Again it is equal to. Now see, this is minus R bar dot A bar minus R bar dot R bar. Minus minus become plus A bar dot A bar plus A bar dot R bar. Again it is equal to. We know that dot product is commutative. Dot product is commutative means R bar dot A bar can be written as A bar dot R bar. So minus of A bar dot R bar minus. In particular, we have the definition of dot product. A bar dot A bar is equal to magnitude of vector A square. A bar dot A bar is equal to magnitude of vector A square. Now here it is R bar dot R bar, so it is magnitude of vector R bracket square plus A bar dot A bar, that is magnitude of vector A square plus A bar dot R bar. Now see, this is minus a bar dot r bar and this is plus a bar dot r bar, both get cancelled. It is equal to minus magnitude of vector r square plus magnitude of vector a square, or which is equal to magnitude of vector a square minus magnitude of vector r square, and it is equal to 0. Why it is 0? Because see, magnitude of vector a is equal to magnitude of vector b is equal to magnitude of vector r. The reason is here, that is magnitude of vector a is equal to magnitude of vector r, because both are radius. So AP bar, its dot with PB bar is equal to 0. This shows that AP bar is perpendicular to PB bar. Now AP bar is perpendicular to PB bar. It means that the angle between them is of measure 90 degree. So therefore, measure of an angle APB is equal to 90 degree. And angle APB is in a semicircle. So hence, angle in a semicircle is right angle, and hence the proof. So in this way we have proved angle in a semicircle is of measure 90 degree. So today we stop it here.